Alrighty, so today we are going to start power series. So if you thought we were coming to an end to comparison tests and sequence and series and all that stuff, then you're going to have to wait quite a bit longer because we are in it for the long haul. We are only getting started. Okay, just to warn you. Okay, but today we're kind of shifting gears and we're combining the power series with polynomials. Okay, so let me show you, let me define this for you. Okay, so here's the anatomy of a power series. Here is the coefficient. And this C is the center of the power series. So these pieces get added up. And I may have to tell you more things as we go. So it's okay if, for example, you are allowed to do something like put a 2n here. That is acceptable. But don't put a fraction. But you can do like 2n plus 1 if you have to do something like that, because that's just syntactic niceness. It doesn't change underlying properties of what we're talking about. Okay? You can also have it be a finite number of terms. So let me just give you these answers to question 1 that I think may be a little confusing. So the question is this a power series? And the answer is going to be yes, and it may be confusing because the spacing between the exponents keeps changing. You can wipe out any number of those into zeros. Like if you want to make zeros in there, it's fine. Okay, so we still have, in this case, we have an infinite number of terms. But even if you just wanted to wipe out a whole bunch of them and just keep a finite number of them, that's okay. That's still going to be a power series. But what is important is that you don't change the center. You're not allowed to do something like put in an x and then the next piece is x minus 7 squared and the next piece is x minus 14 cubed. You can't do that. That's illegal. Okay, so you can leave pieces out, but you can't change the center. That's important. Okay, so hints for question 2. You should be able to get through question 1 already. Question 2A, I want you to play with. It's a play with question, and don't worry about it if you don't come up with an answer, because the quiz question is not it's not hard. The quiz question is not difficult. It's just to see if you can answer some very easy question about the question. All right, so don't worry about it. And I guess that's all I needed to tell you about number 2A. And 2B and 2C, I'm going to want to reiterate, it's okay to use an exponent like 2n plus 1 or 2n minus 1 because it's not inherently changing the structure of what we're talking about. It's just wiping out certain terms, and so the underlying structure is still intact. That's fine. Okay, so that's legal. Okay, now we need more tools so that we can go on to question 3. It's asking you about the radius of convergence, and I need to tell you what the radius of convergence means. Okay, so there is always a number, we're going to call it capital R. It could be 0, it could be infinity, it could be a finite constant, but it always exists, so that for any x's within plus or minus that distance r of the center x, on the x-axis, then the series converges. But farther out from there, it diverges. And this also carries over to complex numbers. So if you see a z instead of an x, don't freak out. That just means they're talking about complex numbers instead of real numbers, and everything works. Okay, so we just use x to make you a little more comfortable, but this whole thing works in complex values as well. And just like what we've been doing already a lot with the harmonic series and the alternating harmonic series, is to warm you up to this idea that on the exact distance r, you're going to have to figure it out case by case. So it's indeterminate, okay? And this value r is called the radius of convergence. So what this looks like in terms of, you know, if you're thinking in terms of I can never draw lines with this thing. There we go. So if you're at c equals 3, for example, you're right here. C is 3. And then let's say your radius of convergence, so c is equal to 3, maybe radius is equal to 7. Well, then all the way out here at x equals 10 is the break point. Like beyond that, it has to diverge out here. It has to converge in here. And 3 minus 7 takes you to -4. X is equal to -4. So what's actually going to happen in the complex plane is you're going to get yourself a nice circle. Okay, so I don't want to draw stripes. It's a circle. And so in terms of the real number line, all this stuff diverges when x is less than -4, and if x is greater than 10, it diverges. And then you would say something like x between 10 and -4 has to converge, but the actual point x equals -4 and x equals 10, we can't actually tell you about. So you're going to have to investigate that, look for sign flippage, see if it conditionally converges, and all that jazz that we just finished doing in the last section. Okay, so those endpoints, you know, honestly, don't get too hung up over it, but think of them as one-off exercises, because what's really important is to understand that there is this thing called a radius of convergence, and it tells you everything about where this guy converges except along this specific circle where you have to figure it out yourself. And since we're strictly in, you know, the x equals real line, that leaves you just 2 lousy points that you have to figure out yourself. Okay, so there's one more tool that I need to tell you about. We're not going to use it much, if at all, but I just want you to be aware of it, because just like we did the ratio test, we also have the, or rather like that we had a whole bunch of just different tools. And I need to give you one more tool in case you want to use it. It's called the root test. And it can be used in this section, but you don't necessarily have to use it. Okay, so if you have a series AN and you want to know if it converges, and there's something in there that has like a square root or square that you kind of think you can get rid of, then you can do the following. You can find the limit as n goes to infinity of the nth root of the absolute value of your terms. Okay, so if this guy, just as before when we had the 3 cases, if L equals 1, we have no clue. This is something you have to investigate more carefully. If L is greater than 1, it's bad, it diverges. Okay, maybe that's sort of, maybe diverging isn't bad. Okay, L less than 1, it converges. Okay, and so you can use this. You can use this in lieu of the ratio test in the following, in this section, if you find a problem that you would like to use it on. Okay, but my example is going to involve the ratio test, but you can use the root test just as well. So if you remember when we had the ratio test before, we would find the limit L, and we would put the AN plus 1, like a term to the right and a term divided by a term to the left, and we would let that n go to infinity. The only difference is now we let the whole piece here jump inside, so it looks like this. Okay, so you just dump all that stuff in together, and then you're just going to solve for x. You're going to find the x values, so that you find the limit equals to 1. So usually you're going to have 2 endpoints. Sometimes you have a radius of convergence that the x value could be anything you want, in which case the radius could be infinity. And then you have the other case, if you find that it only converges right there at that specific point. So if x equals c, then all these wipe out at 0. It's pretty sad, actually. But in that case, your radius could be equal to 0, meaning you only get that 1 point and nothing else, and so you got a lot of work for nothing. Okay, so but most of the exercises don't work out to be that, but we always throw a couple in like that. Okay, so I'm going to give you an example, and I'm going to just put a little plug in for this website. I like Paul's Math Online Notes because it lets you do some of these exercises, and it's really low key. I like kind of low tech here. I like how it doesn't overwhelm you. But I'm going to steal a problem from his website, and I haven't even done it yet. I'm just going to do it on the video and see if I get the same result he got. And if I get a different result, I'll just delete this part of the video and you'll never know, right? Okay. So what is the question? He asked the question, what happens? We want to look for not only the radius of convergence, but the actual endpoints of convergence. If n equals 1 to infinity, here's our series. We want to sum up minus 1 to the n over 4 to the n, and he's going to put x plus 3 to the n. I'm going to go see if I copied it right. Okay, I forgot to put the n in here. There we go. He has an n in there. Okay, and by the way, I want to take a moment to point this out. If you say minus 1 to the n, what happens is when n is even, it wipes out. So if you're starting at n, like if you're starting your summation at n equals 0 to whatever, it will start out positive, negative, like that. But if you're starting at n equals 1, it'll start negative, positive, negative, positive. So sometimes you need to flip that around, and you need to flip which one's positive and negative. So we just write n plus 1 like that, so that it just flips which one is positive and which one is negative. So just keep that in mind for some of the exercises. Okay, so let's go ahead and use this ratio test. And so we want to do the limit. L is the limit as n goes to infinity of all this stuff. Remember a, n plus 1. So let's just go ahead and write all this down, but with an n plus 1 instead of an n. Everywhere you see an n, just write n plus 1. I guess we don't need parentheses here. All right, but there we go. And I'm going to write x plus 3 to the n plus 1. I know I'm going to need to divide by the other one, so I'm just going to stick that guy right underneath, and I'm going to flip my an piece, and I'm going to put it right here. And this looks horrible, but this is what we're doing. And once we do a lot of cancellation, we're going to solve for x. I'm going to find x so the limit equals 1. And so this is all in absolute values. So I think everything looks positive, so I'm going to just drop this and don't worry about it. I think it's all positive, or it's going to be, isn't it? So one thing I notice here is that actually these are alternating signs. So no matter what is going on, one of these is positive and one of these is negative, but I'm going to take the notion that we were supposed to be using absolute values. So I'm just going to wipe out this negative sign. That whole mess means one negative sign. So I just got rid of it. Okay. I also notice that if I look at 4 to the n divided by 4 to the n plus 1, that wipes out and I just get a 4. Okay. Now these pieces, if they can wipe out each other to the most part. And so like I'm just going to get rid of all this stuff. So I've got a 1 in the denominator there. I also know the limit as n goes to infinity of n plus 1 over n. We've done this a million times. That wipes out to 1. So I'm just going to erase all that. And so what I'm left with is just an x plus 3 in the numerator and a 4 in the denominator. So all that complexity just really disappeared, and I don't know where it went. Just vaporized. Now I need to find x so that this goes to 1. Well, let's see. So the limit of n, so n is gone. We have no more n. So we need to see when this guy is equal to 1. So we have x plus 3. We want this to be, the absolute value of x plus 3 should be 4. I thought I didn't need the absolute value, but I just realized I need it again because I need the right and the left-hand side. So this turns into 2 different exercises, and I like to think, well, I'm just going to drop the absolute value on 1 because that problem should be pretty easy, right? So x is equal to 1. should be one of my answers, and indeed it is. Okay, so we're lucky. So we should figure out what the other one is. At this point, you're close enough to the end game that you can just do it this way. You can say, okay, the center is at -3 because I had to subtract -3. It looks like you're going to say, oh, the center is 3, but it's not. It's actually -3. And so if x is equal to 1 is one of my endpoints, and this distance here must be 4. This has got to be the radius here. Then I'm pretty sure I can subtract 4 and get -7. And let's double check. If I put x as -7 in here, do I get 4 back out? I sure do. And so we know that outside, when x is greater than 1 or x is less than -7, we're going to diverge. If we have x between -7 and 1, we converge. And we need to sort of dive a little deeper to see what happens exactly at x equals 1 and 7, which I'll do in a second. But right now, at least, I know that, how did this happen? This is supposed to be a 7. Between -7 and 1, we're good to go. We converge, and we converge everywhere else except possibly 1 and -7. So let's just see what happens at those 2 points. I did get the same radius of convergence as the guy, whatever his name is, Paul. Okay, so, but I didn't look to see what else he said. So I'm going to just test these endpoints myself. I'm going to sort of split this up now into these 2 cases. X is equal to -7 and x equals 1. And the way these exercises are written, usually because there's an alternating thing going on, usually you get one of these converging and one of these diverging, but some of these questions can be written in a really unique way that makes them both converge or both diverge. So just investigate each one, see what happens. So let's see what happens. So we're going to just think about this in terms of what happens if x equals to 1. And it's going to be 4 to the n. The n's wipe out. And that is just completely bogus here. Doesn't converge because it's just +1, -1, +1, -1, +1, -1, right? Oh, wait, I also have an n here. So I forgot the n. It already didn't converge before I had the n, and now it's even worse because it's like, you know, what is this? N is equal to 1. So it's like -1 + 2 -3, etc. This is just really stupid. There's no way that converges. Okay, let's see what's happening with the -7 end of the world. So n equals sum of n equals 1 to infinity, -1 to the n times n over 4 to the n. This guy is going to be another -1 to the n. So these are going to literally wipe each other out. It doesn't matter whether n is even or odd. Both of these are going to disappear. And so then this should be okay, because 4 to the n is going to converge faster than n, but this is a whole separate problem. So let me think about what to say here. Okay, Paul says I'm being an idiot. I forgot to do this correctly. So let me just redo this. Okay. So my -1 to the n times n over 4 to the n, this is actually going to be -4 to the n. And so I can split this off to be 4 to the n times -1 to the n. That's okay. But the point is these cancel and those cancel, and this thing also diverges. So there was no n over 4 to the n. The 4 to the n canceled safely, and all we had left was this n, which the same n we had over here, but we had an alternating series that was ridiculous, and now we have a non-alternating series that's ridiculous. So none of this converges. So it converges, and we already tested the endpoints. X is equal to 1, x is equal to -7. They also diverge. Okay? Okay, and that's the end of that. So if you want more exercises, head over to Paul's website for a couple more examples with done-out answers, or you can just go ahead and do the exercises in the worksheet. And and progress that way. You have plenty of practice with web work and with the worksheet. So hopefully this will start feeling intuitive to you. I hope you find it fun and exciting, and I hope you start to develop some intuition about it, because it's one of the things that seems hard when you first do it, but once you do a few of them, you realize they're basically all the same under the hood, and then they don't seem so intimidating. So just be assured that there's only a few different tricks you need to learn, and this will all be very easy very soon. So you just got to go through them and learn the tricks. Okay? See you in class.